this video, we're going to be talking about oxidation reduction reactions. So a chemical reaction occurs when two or more reactants interact and create new substances. These new substances are called products, and the original substances are called the reactants. The chemical reactions are classified based on the type of chemical changes that occur. We're going to be exploring two different types of chemical reactions, and these two chemical reactions work hand in hand with each other. They're oxidation and reduction. So if oxidation happens, then you can expect that reduction will also happen at the same time. So what is oxidation? Oxidation is where basically where an atom with an extra electron decides to give it to an electron acceptor, which is another type of atom. These two atoms, when it gives the electron to this other atom, it creates a type of bond, more commonly known as an ionic bond. Now, this process is known as oxidation. Now, reduction is almost similar to that, but instead of having it under the perspective of the electron donor, it's under the perspective of the electron acceptor. So the electron acceptor receiving the electron would be reduction, but electron donor giving away the electron would be called oxidation. So oxidation and reduction work hand in hand and happen basically simultaneously. So for example, let's take sodium chloride, or also known as table salt. If we look at sodium, I'm just going to be drawing the valence electrons, or also known as the outer shell. Sodium has one extra electron. Now, the thing is that if sodium was to be stable, it needs to lose this electron. But if it has this extra valence electron, then what that means is that it's unable to be stable. So what it does is that it interacts with a chlorine atom. Now, a chlorine atom has 7 electrons. Now, it has 7 electrons on its outermost shell, or also known as 7 valence electrons, but it needs it has one extra space. Now, if there were by any chance any extra electron that could fit into this extra space, then chlorine would also be stable. Now, think about it. Sodium needs to lose an electron to be stable, and chlorine needs to gain an electron to be stable. So what happens is that sodium will give its electron to chlorine in order for both to be stable. This kind of bonding is known as ionic bonding, and the reactions that happen is both oxidation and reduction. Sodium, which is the electron donor, gives its electron through the process of oxidation, and chlorine, being the electron acceptor, receives this electron through the chemical process of reduction. So this here, sodium would be oxidation and chlorine would be reduction. So sodium would be the reducing agent because it's reducing its electrons, and chlorine would be the oxidizing agent because it's receiving electrons. So sodium chlorine is just one example, but there are multiple other examples. There are multiple other examples, like for example, potassium and hydrogen. Potassium was one extra electron located in its outermost shell, or also known as one valence electron. Hydrogen also has one valence electron. Well, it really only has one electron, but we consider this its valence electron. Now, hydrogen needs one extra electron in order to be stable, and potassium needs to lose this electron to be stable. So it'll again, potassium will go through an oxidation reaction, and hydrogen will go through a reduction action, so that this electron from potassium will be given to hydrogen, so both atoms will be stable. And this will create another ionic bond. There you can also see it with magnesium and chlorine, and 2 chlorine atoms. Magnesium has 2 extra valence electrons, and this chlorine needs 1 valence electron, and this chlorine needs 1 more valence electron. So this chlorine can be stable if it gets 1 valence electron, and this chlorine can be stable if it gets 1 valence electron, and magnesium needs to lose these 2 valence electrons in order to be stable. So magnesium will give these electrons 1 valence electron to each of the chlorine atoms, so that all of it can be stable and again form another ionic bonding. So an easy way to remember about oxidation and reduction is through the mnemonic oil rig, oil or oxidation is loss basically means that oxidation is loss or losing electrons, and reduction is gain. So by gain, they mean gaining electrons. So as further research has been done, just losing or gaining an electron doesn't create the oxidation reduction reaction example. There could be other ways to produce oxidation reduction. For example, an addition of oxygen atoms would be considered oxidation. So for example, 2SO2 plus another oxygen atom will create 2SO3, which is also again oxidation. Then another way you can have oxidation is through a loss of hydrogen atoms. So for example, ammonia, if you were to split this up, you would have N2 and 3H2. So because you're splitting up ammonia to now nitrogen and hydrogen, because you lost the hydrogen atoms, that would also be considered oxidation. Then there's the same thing for reduction, just inverse. So you need to either lose oxygen. So for example, we have carbon dioxide, and eventually what happens is the carbon no longer bonds with the oxygen over here. So then it would be a decrease of oxidation state, also known as reduction. Or instead of losing hydrogen atoms like oxidation, you could gain hydrogen atoms, and that would create reduction also. So we have hydrogen and chlorine, and you have 2HCl. So the hydrogen merges with the chlorine, and because of that, this reaction is known as also reduction. A real life example where you can actually find oxidation and reduction in real time would be like an apple. If you were to cut open an apple and just let it stay there for a couple of days, you would slowly start to see that the apple will turn brown, more and more brown. This creates we can see oxidation and reduction there in real time. This is all about oxidation and reduction reactions.